Welcome back. Super excited moving forward. In this lesson, I'm going to talk about how to frame, in other words, formulate your business problem for a machine learning solution. So here's our overall workflow. One of the first steps, of course, is how to frame machine learning problems, right? And we already discussed when to use machine learning and when not to use machine learning, right? Where to, in other words, apply machine learning technique and in situations where we cannot apply machine learning techniques. So we've discussed that in the previous lectures, and by this time, you're pretty comfortable with that particular concept. So moving forward, right, how do we actually frame the problem itself? In other words, once we actually dive into machine learning, we have to define the problem and then really take a look at what is the outcome that we're looking for. In other words, will this particular problem give us what kind of a prediction or output? So the business problem needs to be, of course, defined very clearly so that everyone understands and the entire organization should be on the same page. Typically, in my experience, it resolves a business problem across the enterprise. So let me give you an example. We have a scenario where individual teams are spread across the world. And here we are. Let's take an example of the email spam problem, right? So you have all these different teams that are spread across different countries globally. So now you need to formulate the business problem accordingly. All right. So the first thing is the training for your data set. So let's say you collect raw data, right? Whether it's structured, unstructured, or semi-structured. Either way, you need to prepare your data so that you have clearly defined the labels and feature engineering. I want to talk about those as well as you move forward. Okay, all these concepts I'm going to cover, and of course, followed by the demos as well, so you get to see the actual hands-on application. But for now, it's just the you take your data, right, and then you train your data. In other words, you first divide your data into a training data set or test data set. So let's say out of a 100% data set, you'll take about 30% and 70%, right? So your ratio would be 30-70 split. Once you have trained your data, then you build a model, right? So you choose the algorithm you want to use. You choose the classifier that you like to use, such as you want to use the classification or the regression, whether it's linear regression, logistic regression, k-means, and so on. There are a number of algorithms that I'm going to be talking about as well. But that essentially is the model, right? A model is defined simply as sort of like, think of this like a mathematical solution, right, for your data. Because you're going to take all this data and then you're going to apply a technique, right, or different classifier, a technique, and then it's going to give you eventually the prediction, which is the output. Okay, so it's input, process, output. Pretty basic computer terminology. The prediction is really what we're looking for in terms of our result, right? Because that is going to tell us what to expect off of our data. But how do we actually go about formulating the problem? So here it is. The first step in machine learning is to decide what you want to predict, which is known as the label or target answer. Okay? Because talk about the same example, right? Email spam example. So we already know that we need to differentiate which emails are good and which emails are spam. Okay, so our target answer is already part of this. So for example, let's say you like to manufacture some products, but your decision to manufacture each product really depends on its sales, whether the product is going to sell or not. So in this scenario, you want to predict how many times each product will be purchased. In other words, you're predicting sales. And there are multiple ways to define this problem by using machine learning. You can choose how to define the problem. Really depends on the use case or business need. Now keep in mind, this also is very similar to the statistical technique such as linear regression, right? Because you're predicting a relationship based on your data, okay? So keep in mind that you want to make sure that this is a machine learning problem or not. But this is how you would actually begin to formulate the problem. Let me give you an example, a couple of different flowcharts, classification algorithm versus regression, right? So in classification flowchart, you would simply pick up how many categories to pick from. So a binary classification simply means 0 or 1, right? Or 2, okay? So either it's click or no click, yes or no, true or false. The value or the categories are greater than 2, then you will apply the multi-class classification. For example, type of animal. And how many categories for a single example. In that instance, it'll be equals to 1. And a multi-class single label, which type of animal is this? And if it's greater than 1, then the question will be, what are all the animals in this picture? Okay, so you get the idea in terms of classification categories. If you were to apply the regression flowchart, then you're looking at how many numbers are in output, whether it is equal to 1 or greater than 1. In other words, more than one output is desired. If the output equals 1, then it's a unidimensional regression. In other words, simple regression. How many minutes of video will this user watch? And if it's greater than 1, then the question would become, what is the, let's say, latitude and longitude of the location in the photo, right? Because there are two variables, two areas that you're pinpointing, latitude and longitude. Whereas in the unidimensional regression, you're just asking for one output, right? The minutes the user will watch. And of course, finally, what to predict. That's the output we're looking for. That's the target answer we already kind of know in the back of our minds. We already are aware of the answer. So do you want to predict the number of purchases your customers will make for each product? And in this case, the target is numeric and you're solving a regression problem, right? So you need to think about that. Or do you want to predict which products will get more than 10 purchases? In which case, the target is now binary and you're solving a binary classification problem. So you get the idea, right? So you need to kind of define and make sure exactly what you're looking for before you move forward. So it's important to avoid the over complicating the problem and to frame the simplest solution that meets your needs. It's also important to avoid losing information, by the way, keep that in mind, especially if the information is in historical answers. So, for example, converting an actual past sales number into a binary variable over 10 versus fewer, right, would lose valuable information. How would it lose valuable information? Because you're specifying either you're using a binary, which means over 10 versus a fewer, right? So both, again, are different. One is the binary classification, and the other one is not specifying the binary number. In other words, you're not predicting which products will get more than 10. In other words, 10 is a specific number. Okay. So investing time in deciding which target makes more sense for you to predict for your organization needs will save you from building models that do not answer your question. Okay. So if you're starting off with machine learning, yes, you're going to get into answers which doesn't make sense because you wanted to really find something else, but the answer results in something else. So initially you will come across these situations, but as you get more experience, you practice more and more, you really understand your business problem and the outcome that is desired, you will get better. So all of these are important when you frame your business problem, right? When you're starting off with machine learning. And again, it's important because if you do not frame your business problem correctly, then of course the entire process is dependent on this first step, okay, so to speak, because the output certainly depends on what the problem is being framed or formulated. So keep this in mind when you're working with machine learning. So I hope this helps. Practice with this. If you have any questions, post in the discussion area. And with this, let's move to the next lesson.